Hello, my name is Vladimir Korikov, and this is the Domain-Driven Design in Practice course, introducing UI and persistence layers. In this module, we will talk about the user interface and the database for our domain model. We will see how they fit the application built with the domain-driven design principles in mind, and how to work with the object relational mapper in a way that allows us to keep our domain model simple and clean. In our client layer, we will adhere to the MVVM design pattern. MVVM is not the primary focus of this course, so I'll keep its description short, just to give you an idea where it belongs in the context of the onion architecture we discussed in the first module. MVVM stands for Model View View Model and is often used in the modern UI frameworks, both XAML and JavaScript based. The model part here is the domain model we discussed previously. The view is the UI layer in our application, and the view model belongs to the application services layer. The idea behind this pattern is pretty simple and yet quite powerful. Often we cannot use our entities and value objects as is on the user interface. It usually requires the data entities and value objects represent to be in a different shape in order to be displayed to the user, so we need to transform it into something digestible for the views. That is where view models come into play. They act as a mediator between the domain model and the UI. You can think of a view model as a wrapper. It works on top of one or several entities and allows a view to easily interact with those entities. The two main elements that enable smooth communication between views and view models are comments and events. They both reside in view models. So when a user interacts with the interface, for example, clicks on a button, this view then invokes a comment in the view model. The view model in turn mutates the domain model and propagates the changes back to the view in the form of events. The view reacts on these events by updating the UI. An important technique that allows this communication process to work is data binding. Following the MVVM pattern, we don't usually update the UI controls manually. A view gets the required data by binding the information on the screen to the properties of a view model. If the view model raises an event saying that some of its properties has changed, the view processes this event by refetching the information from those properties. This technique enables loose coupling between views and view models. Alright, let's see how all this works in practice. I added a new project for our client, DDD in Practice UI. I've made some preparatory work to make the WPF application up and running. You can see common, images and utils folder and a few files here. Don't worry about them, it's just some orchestration and is not essential for the UI we are going to focus on. I also added a view for the snack machine with all UI elements and bindings needed. The details of how those bindings work are not essential for this course either, so we won't dive into them. This is the view model. Currently it contains only a caption string, which is used by the view to display the title of the window. And this is the UI itself. It doesn't do anything at this point, because we didn't define the required properties in the view model yet. And that's what we're gonna do here. We are going to build the view model. Remember, we discussed that the view model acts as a wrapper on top of an entity and provides the functionality required for the view. To implement this, we need to get the entity somehow, so I'm going to introduce it as a constructor parameter and then save it to a private field. You can see the project doesn't compile anymore. That's because we need to pass a snack machine to the view model in the place where we instantiate this view model. I'm just creating a new snack machine object here, so anytime we run the application, it will work with a new instance. We will change that when we introduce persistence for our domain model. Alright, so let's start off by displaying the amount of money we inserted into the machine. It will be shown here near the money inserted label. This label is bound to the money in transaction property, so we need to create one. We can implement it by calling the corresponding property of the snack machine instance and converting the money amount to string. Now, if we run the application, you can see the money inserted is displayed and is currently 0. The problem is that it doesn't change if we try to put money in, so let's fix that. The button that puts a single cent into the machine is bound to insert cent command, creating a property for it and defining it in the constructor. The command will call a private insertSend method, which in turn will insert a single send to the snack machine, like this. We also need to notify the view so that it refreshes the money in transaction label on the screen. This is the technique that lies in the foundation of MVVM I described earlier. A view calls a command, insertSend command in our case, from the view model. The view model processes the call by changing the state of the entity and raises an event so that the view can update itself to display the latest data from the view model. Alright, let's add commands for the other buttons as well. We could implement them like this, introducing separate methods for each of the command. But it's easier to create a single one and just pass a required money instance to it. So here I'm passing 1 cent, 10 cents in this method, and here are the other 4 commands. So now if you try to put money into the machine, you can see the money actually go there. The money inserted label displays that. One thing we can adjust in the way the money amount is displayed is we can put a dollar or a cent sign in front of the number. It's a good idea to implement this functionality in the money class itself by overriding the toString method. So if the amount of money is less than $, we are returning the amount of cents like this. Otherwise, the method returns the number of dollars. And it's a good idea to also add a test for this method. You can see if we create a money instance with a single cent, we expect the toString method to return a 1 cent string. For a single dollar it should be $1 and so on. Starting from this module, I depart from the test-first approach we discussed previously, just to speed the development process up, but keep in mind that it's a good idea to adhere to this approach in this particular case, because we know exactly what we need the toString method to do. Now I can remove the amount property from here and just call the toString method on the money instance itself. And here we go, the nice symbols are now shown in front of the inserted amount of money. The next thing we can implement here is some informational message to inform the user about the last action they performed. So let's add a message property in our view model. It's a simple property with a backfield. I put the notify method call in its setter so that it automatically notifies the view whenever we change its value. We won't need to do it ourselves like we did with money in transaction. Also note that we don't specify the name of the property here. If we don't indicate a name explicitly, the notify method just gets the name of the method or property it is being called from, message in this case. And that's exactly what we need here. We can use this property in the insert method by assigning it you have inserted wherever amount of money is passed to the method. And we don't actually need to call toString here, the compiler will do it for us. So now when we insert a coin or a note to the machine, we get a nice message here. The next thing to consider is the return money button. Let's add a command for it. The method itself calls the appropriate method on the snack machine class, notifies the view to update the money inserted label, and updates the message. If I put 11 cents into the machine and return them back, you can see the money inserted turns back to 0. Alright, we still have this whole section inactive here. It requires a money inside property, so let's implement it as well. A nice thing about bindings is that they can work not only with string properties, but also with complex data structures. In our case, the money inside section on the screen expects a property of the money type. To implement it, we can just sum up the money inside the machine and the money that is currently in transaction. It makes sense because we don't need to differentiate the money that belongs to the machine from the money inserted by a user and can just show both of them as a whole. Now, as we have another property the view is bound to, we need to notify the UI when we change anything that can affect this property. In our case, both return money and insert money methods can affect the money inside, so I add a notification regarding this property to both of them. You can see as we put coins or notes to the machine, the view reflects the actual number of them and the overall value they represent. Very well, the last thing we need to do here is we need to implement the buy-in functionality. So I add one more command to the view model, and define a private method for it. In it, we need to delegate the execution to the snack machine entity, tell the user they have bought a snack, and once again notify the view about both of the properties. Now, if I insert, for example, $3 and buy a snack, you can see the money inserted is discarded, which means all inserted money are now the property of the machine, and we cannot retrieve them back. In contrast, if I insert some money and return it, both the money inserted and the money inside revert to their initial values. Very good, the first version of the user interface is ready. But before we finish with it, let's do some refactoring. First of all, in the insert money method, the name of the input parameter doesn't actually reflect the meaning of it. We are not inserting just some arbitrary money inside the machine. We can only insert a single coin or a single note, so let's rename it to coin or note. Perfect. Secondly, you can see some duplication in the way we notify the view about the changes the commands make. All three methods do essentially the same here, the only difference is in the messages they use to show on the screen. We can extract the notification portion to a separate method, notify client. Now we can just call it in all three methods with different messages. Finally, note that we are passing literal strings to the notify method to specify the names of the properties. That might lead to problems if we decide to rename those properties and forget to change these strings. In this case, notification would no longer work as intended. To avoid such situations, we can use another feature C#6 introduced, the nameOf operator. So instead of the literal string here, I use nameOf money in transaction, and the same for the money inside. Now, if we decide to rename one of these properties, the compiler would notify us in case we forget to also change these lines here. Internally, the compiler just replaces all nameOf invocations with strings, so there are no performance drawbacks in this solution. In the previous demo, you saw we built a UI and application services layer. In our case, the UI layer was represented by XAML views, application services layer by view models. In ASP.NET MVC solution, for example, controllers would act as application services, and HTML views would be the UI layer. The application services layer usually acts as a mediator between the outside world, which is user interface, and the domain layer. This layer itself shouldn't contain any business logic, only coordinate the communication between different elements of the domain and validate the inputs from the UI. In our case, the view model we created acts as a wrapper on top of an entity. It augments it with the functionality required for the view. It didn't contain any business logic, but rather delegated it to the entity. Application services can work with other domain classes as well, such as repositories. You will see it later in this module. It's important to find a proper place for the logic we are adding to our codebase. Some of it makes sense in the domain layer. For example, you saw we implemented the toString method as part of the money class. Other logic looks better as part of the application services layer. For instance, when we were working on the money inside property, we added it as a part of the view model. You can use the following rule of thumb when you want to decide between the two. If the piece of logic you are looking at makes sense only in the context of UI, then it's probably better to place it into an application service, view model in our case. Otherwise, it should be part of the domain layer.